Hi guys, this is Ashrith and today we're going to talk about geometry, and in geometry we're going to talk about spiral similarity. So spiral similarity is a very useful concept what we are going to learn before isometry, complex numbers and rest. We're going to do some complex numbers spiral similarity now. We'll see if we have time for isometry, if we finish spiral similarity fast. So if we have a line like this. So let's talk about homotety first. What does homotety mean? Homotety mean. So if we have a triangle with 60, 50, 70, and if we have a smaller triangle which is a similar triangle to this, 50, 70 and 60, we know that this triangle is ABC and this triangle is DEF. We know that AB by DE equals to AC by DF equals to BC by EF. So we know all these three conditions because due to similarity we say all these conditions are right. So what we could say, if I zoom this triangle by something, maybe 2 or 1.5 or 1.7 or something, we get something like this: 60, 70 and 50, and I try to overlap here. In this case my drawing is not so good. So what I'm gonna do is I'm gonna select this triangle, and yes, so now we have another triangle. So I'll name this so you can ignore this triangle, and I say that when just a second guys. Yeah, yes, so yes, so I say that this triangle, when zoomed, I get this one, which is DEF. And now I select, so I have zoomed the triangle DEF and made it bigger to the other DEF. So I'll change the name. So I'll call this D dash F dash E dash. Now after I zoom the triangle DEF, I'm gonna just a second guys. I'm gonna select this triangle, the D dash E F, and I'll try to place it exactly over A B C. You see it matching. It is getting matched. So we say that two triangles are similar when I do the homotety, which is nothing but the expansion, or you call it zoom also. I have zoomed this triangle to this. You can see this guys here. So we're gonna learn. So this is nothing but homotety. we have learned homothety. Homothety is pretty similar, it's pretty simple. Homothety. It's a really simple concept. So we have learned homothety in this. So we could see a couple of examples more. We'll see it in spiral similarity. So now let's come to spiral similarity. So the homothety is pretty simple. So now let's come to spiral similarity. The heading is spiral similarity. So if we have two lines like this is one line and this is the other line. Now I join the ends, which is something like this, and I join the other end, something here. Now what I do is I draw circumcircle for this triangle. No. Okay, let me draw with my hands. It wouldn't be so well, but try understanding this, guys. I have drawn a circle like this and another circle. Let me use eraser. It's pretty horrible. Yeah. Gonna draw another circle here. So what does spiral similarity mean? So spiral similarity is nothing but rotation. Is nothing but rotation plus homothety. So I'll explain what rotation is, guys. So if we have a coordinate axis and I have a line here, this is A comma B and this is C comma D, and rotation is nothing but in clockwise or anti-clockwise by theta. So I say that I have rotated this line. Let me give this a line name, which is L root theta. By theta I have rotated anti-clockwise. So this is nothing but rotation. It's pretty simple. And homothety is nothing but just the zooming in and zooming out. So what we need to prove is, guys, that we need to prove that this point is the center of spirality. It shows spiral similarity here. So now, as we know, these two are straight lines. I mean this line and let me write the names AB and CD. We know that AD and BC are straight lines. So let me use a different color. Let us take green, because AC I mean AD and BC are straight lines. We say that this angle is equals to this angle. Now what I do is I join B and this point O. Oh, just a second, guys, it's coming pretty horrible. Yeah, let me just a second. Yeah, so I'm gonna join, this is O, I join O I'll join. No. Not getting this properly. And I'll extend this one here, and I will join O and C. And similarly, I will take another color pen, which is a yellow color, and I will join O and D, and I will again join A and O. Yes. So we say that triangle BOC is similar to triangle BOC is similar to AOD. It is simple. Just a second, guys. It is simple angle chasing, so let me do it. So I'm gonna join this point as F. I'm gonna join OF through simple properties of circle. We know this angle is equals to this angle, and similarly this angle is equals to this angle because OF is the chord, and then we say the other angle is equals to the other angle. So this is very simple, guys. These are just the simple properties. So we have proved BOC is similar to triangle AOD. So I'm gonna rub these points, which makes the diagram horrible, the black ones. So we have proved triangle BOC is similar to AOD. Nope. Control 5. Something happened. Yeah. I'm gonna use the eraser. Oh, okay, never mind. So we have proved this this one. So we have proved this one. So now we know that this angle, when we rotate it through the point O, so this one, the point A will fall somewhere on BO. It will fall somewhere on BO, and it's the same angle. And OD, the point D, will fall somewhere on C when we rotate this thing. Rotate angle AOD such that A will fall on B. That time we also find out that O will fall. D will fall somewhere on OC. So now we almost proved it. So we have the diagram something like this. Let me just take out the points again. Yes. So we have proved right now that OD when rotated will fall on somewhere on OC, and A will fall somewhere on BO when we rotate angle AOD. So we get something like this. This is D and this is A. And when we zoom it, when you use that homothety, because both the triangles are similar, we can overlap both the triangles, which is B, C and BCO and AOD. So that is just about spiral similarity. So now we have, by proving this one, we have already proved ABF, because similarly you can say uh, CD, when we rotate similarly, it will fall somewhere like this. This is C, which would be C. This would be D, and this would be F. And when we use homothety, I mean this would be C. When you use homothety, we can show that ABF will fall on, no, I mean FCD will fall on ABF. We can prove this. We have proved this by proving that triangle BOC, I mean triangle AOD, will fall on BOC. So that's all for spiral similarity, guys. This is the simple concept behind spiral similarity. Spiral similarity is a very tough concept to understand. So let me wrap it up by using another page. Spiral similarity. Yes, so now let me wrap it up. So if we have two lines like this, and if we join both the lines, and if we draw circles through them, so at this point we say that this point is a point of spiral similarity for the triangles A, B, F and C, D, F. So that is everything for spiral similarity, guys. I know most of you wouldn't have understood, so pause, see the video again, because spiral similarity is a very tough concept to understand. And that's all for the video, guys. Thank you. Please subscribe to our channel. Please subscribe to our channel so that we could get we could do more and more teachers like these. And once I hit 1,000 subscribers, I personally know the spiral similarity is a very tough concept to learn.